Hello everyone, it's May the 5th. I was working on the app again today, and I got into a very weird bug. Very, very weird. I think it's a bug in iOS. It's so when you set up a user registration screen, right, you will need to have password and confirm password. So both are considered secure entry, secure text entry. That's a special type of entry that React Native provides for this text input component. So you put both as secure text entry, and then if you're typing it, at least from my side, if you're typing it using your actual physical keyboard, and then you press return with the virtual keyboard, and then there's a yellow box showing across both inputs and saying something like strong password. It's this weird thing. Just I didn't intend to have this yellow box show up. I didn't intend to have this strong text, strong password text to show up. And then once those show up, the text box is no longer useful, and then you cannot input anything more. So this definitely is a bug. And then search online on React Native. Definitely, there's a issue open 2 years ago. Oh, hold on, 2018. That's 3 years ago, right? Almost 3 years ago. I forgot when exactly in 2018, but let's just say 3 years ago there was an issue about this exact problem. And for all this time, it's never been fixed, and people constantly just complaining on that thread and sharing their workaround. I mean, I don't know why it happened. I don't want to dig into it. I just want to know like if there's any way to solve it or there's any workaround. But apparently, the workaround provided is I don't feel like it. I don't like those workarounds. So I tried some methods myself and find a method that works for me, and I shared on that thread as well. It's just overall a very weird experience. I mean, if you think about it, this is a very very critical bug, right? It can cause the app to be unusable, but it's still there. Well, I mean, the app might still be usable because from my experiment, this happens if you mix and match. You mix the physical keyboard with the virtual keyboard. So it probably is just a bug during development, right? In actual production, all the input is going to be from virtual keyboard. So probably there's not going to be an issue. It's just when you develop, you have two. I like to always mix and match. I don't know why, I just like to do that. And then this happens. Anyway, maybe that is the result of a fix. Maybe in the past, uh, you type in the virtual keyboard alone or physical keyboard alone, it will have the problem. But now it's a mix and match. If you mix and match, it has the problem. So maybe that's what we see now is what I see now. Maybe it's a result of a fix. But anyway, it's just very interesting, right? Interesting and weird, and a waste like about 1 hour, wasted 1 hour from my time. That's always not good. All right, anyway, let's take a look at today's LeetCode challenge. What do we have today? Jump game number 2. I definitely have done jump game before. Not sure if it's number 1 or number 2. Given an array of non-negative integers, you're initially positioned at the first index. Each element represents your maximum jump length. Your goal is to reach the last index in the minimum number of jumps. You can assume that you can always reach the last index. Minimum jumps is 2. Jump 1 step from 0 to 1, and then 3 steps to the last. Jump 1 and jump 3 steps. Yeah, I think I've done this before, but I obviously don't remember how it was solved. So 2, 3, 1, 1, 4. So the number represents the maximum number of jumps you can make from that position. No clue. No clue. Let's see. So we want to wait. So the jump can be both direction, right? The jump can be both direction, but why would you want to jump back? I mean, you don't want to jump back. If you can, so the only think about it, if you want to jump back, why do you want to jump back? Because you think jumping back will give you a better chance, right? For example, if going forward is all ones, like 1, 1, you have to go all ones. Therefore, I say I go back, then I can jump further forward, all right? However, this is not really necessary because if I can reach a further point, right, then it's definitely possible that I can reach a nearby point. I can save a jump. So we don't have to consider jumping back. It's always going to be jump forward. Okay, so if we always want to jump forward, the idea will be we want to use the longest jump to go to the end, right? Does that make sense? Like if we can find a position where we can jump, like using one jump to reach the end. If we can use one jump to reach the end, then that, hold on, I have something coming up. All right, I'm back. Let's go. Again, where was I? I said I want to jump forward. I said that the theory is if I can find a step that I can do one jump to reach the end, the largest of them, then that is desired. Does that make sense? Well, I mean, if we have one, that has the maximum. I shouldn't say maximum. I mean, if the maximum doesn't reach the end, but it can still. I mean, we always want to jump from the maximum, right? Not necessarily. If the maximum is like further down, close, if the maximum, like if we have like 100 here, right, there's no point of coming here because we can do it this way. So if we have, no, I think this is not the right way of thinking. I think this is going to be a dynamic programming. Yeah, I think this is going to be dynamic programming. Like we can compute the minimum number of jumps to reach target from each single one of them. And then, like, if I know from here, I need to take one jump. From here, I need to take two jumps. From here, I take one jump. From here, I take two jumps. And then that we can solve the problem. We go back, forward. So this is definitely one jump because it's right next to it. And this one depends, right? Depends on where it can reach, right? On where it can reach. So we're gonna have to loop through. That's why it's 1,000 because it's gonna be O(n) squared. So for each, we can loop through all the positions that I can reach, and I'm gonna pick the smallest. That means I can jump there from the smallest, and then I jump there. So yeah, all of that we can reach, and then we pick the smallest. Yeah, and this shapes out to be very, very nice. shapes out to be very nice. I think I'm going to code it that way. I think that is a solution. It's almost, how should I say it? If this is dynamic programming, which I have a high confidence that is, and based on the the lens, it's definitely possible. This is the solution. Man, I've been using I've been using the Vim for like is that about a week? I don't know. I don't feel it. I don't feel like I still the up down left the arrow keys are still the most natural to me, and I have other like muscle memories on how to move the cursor around. The HIJKL is just doesn't work very well. Plus, the issue is if you're in insert mode, right? And I want to move the cursor around while in insert mode, it's impossible. I cannot. I have to exit and then move around. And then once I move around, I have to go back to insert mode. But if I use if I use left and right, then I immediately can insert. It doesn't disturb. And for example, if I want to delete this whole thing, my muscle memory is go to the end and select them, then delete, right? But if I want to do it using Vim, based on my current knowledge, I mean, I know Vim is very, very powerful, but based on my current knowledge, I have to do this. I have to think I need to go to the front, so I'm going to type B and then CE, right? That's my current way of approaching, but just because I need to type B, so that's another I have to look. But if I go left and right, and I use like left and right on the command key, I don't have to look. I mean, I still want to force myself to use it, so maybe like a couple weeks, and then it'll get better. I don't know, man. Anyway, so this is going to be like right now, right? I want to go to after the right bracket, and if I use this immediately, if I don't, I have to exit and then type this. So I don't know what is the best way to approach this. I mean, the idea is that your hands were always around the keyboard. The ESC is pretty far away, and the arrow key is like 2 down, so you have to move your hand. You still want to move your hand. And sometimes I like to use like this to locate where things are instead of jumping to like it's more visual, right? It's more visual. Maybe I'm just fighting something like right now. What do I do? If I just do this, or I have to go here and then we say when I go to 7. Oh, it's actually better that way. Anyway, that's nothing to do with what we're doing right now. So dp equals this, and then 4 I in range, len nums -1, -1. Actually, not -1 because that's the last one, so we don't have to. So this is going to be -2, right? And then we're gonna go to the end because we want to insert this. That's not working. Wait, I think the no, here. I think we are missing a tab. Go up, insert tab. Okay. And then we're gonna go down, and then insert. There we go. So I'm gonna say for what? For J in range. Okay, for J in range 0 to minimum, right? Min what? Now I'm using arrow key. Yeah, I said use it wrong. Ha! But this is good. I like this one. Can find. So minimum either let's len nums appear too many times. Up and down is still an issue. N equals, I think that's a lot, equals len nums, right? And here, so come on, and we select, right? And then we're gonna say D, and we're gonna say C, call N, right? And then we're gonna go down. Minimum nums, right? Nums I plus, hold on. No. That's not right. This should be from I. All right, J is from I. Hold on. It's not I. It's I plus 1. I plus 1. So here is I plus 1, right? Until I plus, no, minimum I plus nums I, right? So for example here, nums I is 2 and I is 0, so that's 2. So 0, 1, 2, right? That's the furthest we can reach, right? So the minimum of this, and it's not going to be this, so it's going to be this, and n. What? N. And this, I think I'm going to also do plus 1, right? So that's the minimum of reach the end, right? J from this reach the end, or I plus nums I plus 1, which means the longest we can reach. So for here, this plus 1. Yeah, I think this is correct. We're going to say here for J in this, dp, right? dpi equals min, dpi, and 1 plus dpj, right? J we can look through, and then it's going to be the smallest. And then when we're done, we're going to return dp0. Okay, and we're going to make some changes here. Don't do this. Come down here, go to the front, and do 0w. I'm going to select here, go up, K, delete all this, and we are going to go up and test case 2, 3, 1, 1, 4. This one gives us 2. Next one is 2, 3, 0, 1, 4. So I'm going to 2 as well. And now I'm gonna also do here. Find this. What is this? Oh no. Oh no. There we go. It's a capitalized letter. And we can say, how do we delete one letter? I mean, like, that's, anyway, so that's what? Nums, right? And, I mean, I like CE a lot. See, you delete the entire word, jump. and come here. No, like every time we have to do. Okay. Oh wait, that ain't right. That ain't right. I is 0. Yeah. I plus 1. So I initially is 1, 2, 3, 4, 5. 5 minus 2, 3, 0, 1, 2, 3. So that's here. And then J is going to be this, and plus mean I is 3. 3 plus 1, 4. 4 plus 1, 5. And then it's also 5, right? So from 4 to 5. So dpi equals min dpi. Oh, oh yeah, I ain't right. I ain't right. Oh man, what did you do? Nums. Hold on. So it cannot do 0. I was not right. Cannot do 0. We have to do the maximum value. So length is 1000. So 1001, right? And then all we need to do is, after this, we set dp minus 1 equals 0, because the last one is. And now we run. Now we pass everything. Okay. No, not I. We need to go up. So we have a. So go to the end and delete this. And then go to line 14. And I'm going to say C. Yeah, C does work. Okay. Now, okay, when the select, so go to 5, V, go down, Control C, and come in here. Let's run some test cases. For example, if only 1, oh, I should pass. That should be 0. Don't need to do. Yep. Let's run it. Pending. Except, yeah, that is the solution. It's a standard. Here, right? So say standard DP problem. That's it. I don't think there's anything more to say. It's just a regular DP problem. Let's just say we use a DP array to record the mean number of jumps needed to reach the end from each position. We go from right to left for each new position. We loop through all possible end points that is reachable from the current position, and pick the mean jumps among them. Yep, O(n) squared. That's why we have only 1000. And what's the runtime? I think it should hit maybe 50% ish. Yeah, 33%, 36 millisecond, 33% ranking. That's fine. It just means it's a regular. We did a regular solution, nothing special. All right, I'll be back very soon. Oh my god. Alright, I'm back. Just put the cat to sleep. No, it's just have a little ritual, a little bit routine that we do with our cat whenever we went to bed. Alright, let's see. This shall be maybe, I think that's a medium. Yep. Yeah, look. Oh my god. Jump game 1, 2, 3, 4, 5. Oh, I think 5 is a hard one. I've done many of the jumps already. So the jump game 2. It's just a basic DP solution. I think I've done it before. Oh my god, I've done it so many times. Ah, I have improved. Tremendously improved. Look at this. Look at this. 2 years ago, right? I did, what was my initial solution? Can jump directly to the end. No more jump. Yeah, I was trying to analyze it. Now, this type of problem cannot analyze. Oh, time. And finally, I think start here. Couldn't do it. Oh, I did it. Eventually, I did it. Try here. Oh, wow. Oh my god. Ha! I was very determined back then. I think I was given up by this point. My goodness, what the heck is this? I mean, with no comments, this is not gonna work. Oh wow, so, but I know it's bad. So the next day, I have a memory. Oh, I was trying something else. Adjacent wait, what was I doing? Adjacency matrix. I was using different methods, huh? And I had memory limit, time limit, and then what is this? Oh, how did we resolve the issue of memory? But this is much easier. I don't know if I came up with this myself or I checked the result. I don't know what this is. I don't want to read it. And what is this? This must be some modifications. I'm trying to see if I can get it faster. Yes, I did get it faster. And oh, the next day, this one lasted a long time. This is 6:30 and at 8:30. And the next day, I tried it again. 88. What is this method? It's all Python, right? Yeah, it's all Python. Furthest jump. Update the starting position. This one looks more like oh, this is what? This is a BFS? The furthest index that can be reached. Current level start. Next max jump +1. Traverse through the current level to find the furthest jump. Next max jump equals max. Next max jump. And I plus if next larger to a further jump already reached the end, we're done. We're turned stuck. Otherwise, we update the start of the next level. Yeah, this is this is BFS. Yeah, this is BFS. Yeah, but we just go from start to end, right? Going from start to end, try to find the maximum steps that we can get. So every time we record the maximum that we can get from the current level, and then we go to the next one, because if you see the I, oh, so at each, hey, how is this going to be optimal? I in range current start, and then next max jump plus 1, and then we try to find the next max jump. Well, it's actually not next max jump, it's just from the current level. What is the current level? The current level is all that I can reach in my in the current level, and I will try to find the next max one. If it's not, then the next level will be the current level plus 1. Oh, I examine the entire level. We think about it as the level, as the entire level. So on my current level, I try to examine where I can go. All the nodes that I can reach are considered to be a level, right? And we find the maximum that I can reach from the next level, yeah, and then I go to the next level. Yeah, I go to level, we find the maximum we can reach in the next level, right? And then we go to the next level, go through everything in that level to see where is the furthest we can go. And we basically move level to level. Yeah, it basically move level to level. Yeah, from each node, from the first node, we can go to certain number of nodes, and they are right from the starting node. I can go to certain number of nodes, and they're at the second level, and then we go to the second level, go through everything, try to find the furthest we can go, right? So everything that the second level can reach will be the third level, and then we go to the third level. Okay, I see what I was doing here. Okay, that makes sense. And I have a 12. Oh, that's CPP. That's a CPP method. Is that the same? Yeah, I think this is still the maximum jump. It's the same idea, but I think the DP method is more straightforward. It's more straightforward. All-in-one loop Java solution based on greedy. Okay, let's say the range of the current is current beginning point. Our farthest is the farthest point. And all points in can reach. Once a current point reaches current end, then trigger another jump and set the new current end with current farthest and keep both. Okay, current farthest is maximum current farthest, and I plus AI. Okay, if I equals current end, jump plus plus, current end equals current farthest. No, I don't think, is that BFS? Yes, it's a BFS. All the items implementing jumps like incrementing the level you're on, and the current is like getting a queue size. The next level you're traversing. Yeah, this is. Hold on. So we don't have to go. So my code is we have the current level, right? And then we jump to jump to everything that I can. No, oh, yeah, you don't have to. We don't have to know. We don't have to know all the intermediate. We just need to know the furthest you can go. Right? From my point, the furthest I can go, right? And then everything between me and the furthest I can go is all the other nodes that I can go, but I don't have to worry about them because I go through them as well. So I go through every one to find the furthest I can go, right? And then how do we determine when the level is over? So I'm here. So we need to know the current end, right? And then we reset the current end. This is good. This is good, but I want to code it myself. Yes, ON. Straightforward. Easy solution. 8 lines. Easiest solution. 8 lines. 1, 2, 3, 4, 5, 6, 7. 7 lines. How about that? Oh, has anybody used DP to solve this? Greedy. I don't think that's like greedy. It's just BFS. You want to post? Yeah, DP, but yeah, people write DP. Greedy ON. Yeah, that's right. Oh, no, not this one. DP. We can write something. Actually, let's see. Newest. Somebody might have written something. DP solution. Nah, it's already DP out there. All right, this is no need. But we are just going to implement the ON solution because this one is ON squared, right? We don't want ON squared. We want ON. So we're gonna do. Oh no, that's way too much. I just want to yank this. Go to 22, line 22. Go O P, and we actually also need to set this to be as 1, right? And then 24. We set here. That's gonna be 2. Right? Okay, so we want to go 1 round, right? We need to know the current level. So we're going to say res is equal to 0, right? 0 jumps. And then every time we reach, oh no, what new yeah. So for each one, right? For each one, we can compute the furthest we can jump. Each one will compute the furthest we can jump, furthest we can jump, furthest we can jump. And we're going to record the furthest we can jump. And that will be our hold on. So this is what a current. Oh, sorry, I didn't hear it. Where am I? The current. The current we can jump to. Let's bring my cat right here with me. Just kissed my cat. All right. So we need to know the range, right? When our when our index going past the range, then we're going to increment the jump. Yes, so the range going to be current end. I like how this one sounds. Current end is going to be 0. Should we say current start as well? Current start and current end. We don't really need to set current. So we say for I in range len nums, right? We go each one of them, and then next end, right? We say next end equals max next end and I plus nums I, right? That's the maximum we can reach. Yeah, I plus, that's the maximum we can reach at the current level. And then we need to see, right, if I has reached the current end, right? If I have reached the current end, then, like, if this equals current end, no, it's not, it's larger than equal to current end, right? It means if I've reached the current end, then I say, if I reach the current end, then I say arrest into plus equal 1. We just jump to the next one, as that's like, well, we'll finish the current level, right? And then what? And then we reset next end, right? So we set next end, no, current end equals next end. Then next end equals 0. We reset the next end. And then we keep going. We need early exit. How do we early exit? So if the next end is, if at any moment, right? If at any moment, we say if at any moment, if next end is larger or equal to, we're also going to do, I'm going to go to 27, so we will do current end. Oh, what did you do, man? That's just, sometimes you forgot. You have to push this. You say next end, current end, 0 and 0. And we're gonna go up. This is going to be n equals what? Equals len nums, right? So all the len nums will go down, 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 go to the front B, E, and no. We're gonna go W. No, B. I'm gonna say C, E, and go here, C, find this, N, right? And going down. So we say if this is larger than or equal to N, then we're gonna return res, right? It's already. Now we're gonna return res. Otherwise, we're gonna do this. We're gonna do this. Current end, next end this, blah blah blah. And then we're gonna go and return res as well. Okay. So I think we can also make 34 a little bit simpler. So instead of do this, we can say current end, next end equals, yeah, so we're gonna go to the end, next end equals next end 0, right? And then we can remove this line. All right, so now we need to test it. So go to 38, right? And then find this, insert 2, try it. It passes as well. So we're gonna do 24, select, do this. I forgot to do the V, then select C here, then that's right. This is BFS solution with a single pass. Let's try it. Oh, it ain't right. Oh. Next and equals max next and I plus, I think it should be n minus 1. Hey, what the hell? Alright, we gotta test more. Oh, I don't know. I thought n minus 1 has other issues, but anyway, so the one that got me into trouble is this. No, 0. Not n minus 1. Next n has to be n. Huh. Next n, I plus this if it's larger than n. Well, n is always 1, right? And I plus, and if it doesn't move, it's a 0, so it does not move. Why n minus 1 doesn't work? I plus num. Hold on, let's see. If this, what do we have? We have 1. Because, yeah, next and, huh. To return rest plus 1? Yeah, because next and is next end is where we can reach from here to the next, right? That's the next one. But we haven't made a jump yet. We made a jump when we reach the current, then we jump to the next one, right? So then that's when we jump. So if this is going to be return rest plus 1, but we have the same issue, which means, but this is correct, all right? This is correct. Now we find it, then we can end it immediately. But how about this? Well, I mean, we can add like a special condition, right? We can add a special condition, say, but I feel like it's possible also not to add a special condition. I mean, next and is going to be 0, which is itself, right? Which is itself. All right, I'm taking a look. Taking a look. Oh, no, not this one. Hot. No. Most vote. Max. isn't that the same? Current end equals current farthest. Yeah, that's true. We don't have to set next end to 0 because next end will always be bigger. Wait, but how do you? What if it's only a 0? Oh, a dot length minus 1. Ah, that is the trick. That is the trick. We don't consider the last one. Why? Because in range, yeah, because the last one doesn't matter, right? The last one's already there, so we don't have to consider the last one. Hold on, let me group my thoughts on this. So we do at each node we compute where's the furthest that we can go in the no, from each one we compute the furthest I can go, right? Then that's the limit for the next level. Then I go on to the next one, right? And then for each of them I also compute where they can go the furthest. And then when they reach the current end, we know that's one jump. That basically is one jump. And then we go to the next jump, right? And then if we reach the target, anytime we reach the target, yeah, this is actually, I think, it has to be this. Anytime we reach the target, is the n minus 1. Yeah, if at any time from any node, if I reach the target, but we haven't made that jump yet, right? We haven't made that jump yet. We just say at this point, the furthest I can go is here, but I haven't made the jump. I haven't jumped to the next one yet. So we're here and do rest plus 1. That is correct. That is correct. And the thing is, we don't have to consider the last one because the last one, there's no point. There's no point to see how far you are. This is the trick. Yeah, I'm gonna say this is the trick. This is the tricky part. Do not include last position. Okay, so we have is then they will pass, and I think it will also be fast. So what I'm gonna do is also add a few commentary here. So this is a BFS with a single pass. Courtesy reference. Yeah, always include the reference code. Include this. Yep. Yeah, this is BFS, and we can also 37 line 37. Current n equals next. Next, we don't have to because this is the n, right? And then as we keep moving on, this is always going to be bigger than the next n. Therefore, we do not need this. There we go. So again, we're gonna do this. This one shall be correct. Of course, don't include this. Submit. I think this one's correct. Yeah, it's faster. Yeah, much faster. Well, not much faster, but it is faster. All right, 2 solutions. This is better. This is much, much better. All right, that's it. That's it for today. We did a good one. I mean, we improved. It took 3 days in the last time. Well, it's not 3 days. We did solve it here, but we did also take a look. It's horrendous. It's horrendous. And now we have this, right? It's nice and clean and O(n) squared. Not the best, but it's it's good. It's good enough. All right, that will be it for today, and I'll see you guys tomorrow. Adios.